Right, well, we're going to demonstrate the walking the cup technique for the route next, Travis.
Oh yes, yeah. What we'll do is we'll, it'll be nice if we kind of take this thing, kind of scoot it around so that this scoop on now is over here, so the camera can see a little bit better, and the viewer, and so yeah, we're going to be just swapping up techniques and still using the Dynasty 400.
Okay.
Yeah.
So Travis is looking through the gap master, knocked out the freehand. Now we're going to set this up as kind of a tag team situation where both of us will be welding. Now on this size of pipe, it's not quite practical for both to be at the same time, but for demonstration purposes, we'll make it work. I'm going to start with walking the cup on the bottom, similar feeding technique, but now instead of freehanding, it's going to be walking the cup. So Travis, why don't you tell them about it, and I'll start rooting.
Yeah, so basically while Dakota's welding, I'm going to be just going like this, simulating a pipeline in like southern,
Thanks.
somewhere else other than the world.
Thanks, Travis. So yeah, instead of looking through the gap from the top, this is more of a line of sight right on the puddle, while still slightly looking through the gap at it.
So the reason why we're doing this, you see, when we both started at a company called Legion Piping Fabricators in Nisqually, Alberta, and they will be opening up a pipe fabrication shop in Houston, Texas. So look out for us. We started out doing, say, like 52-inch, 304/8 stainless steel piping, 688 wall, 48-inch, 24-inch, 24-inch, 16-inch, different size of pipe. And it was just for more aesthetic route pass. It was just easier if we used walking the cup technique, but it's more uniform. There's a lot more uniformity to walking the cup. More even ripple definition, technique, everything.
So a big part with our technique when we were getting the hang of it is we were getting used to our tungsten stick out as well as cup size. And it plays a crucial part in this. Now depending on your bevel size, your pipe size, and your bevel angles, that's going to change your cup diameter as well as your tungsten stick out, because what you're aiming for is to have that tungsten pointing straight in, just a slight push towards your puddle. If it's too far and you're shooting too far forward, your puddle has a high chance of dropping on you. And so it took us a bit to fine tune it, but we got dialed in and we found out that's what seemed to work the best for us. So another thing with big bore, do you want to talk about the angle of filler wire, Travis?
Okay.
On big bore?
Usually on big bore, it's much easier just to kind of feed where there's a tack. So use a tack as a brace, and you can kind of feed in for the tack. A lot of welders will kind of contact me, and they'll ask about like they have like rod stubs essentially melted off in the weld puddle, and that's a combination of having the filler metal at too steep of an angle, or sorry, like too much of an angle, so it melts off on the side of the tip of the filler metal, rather than the tip of the filler metal. But also at the same time, when you're using this technique, you can actually have your line of sight line up so where you're pulling the weld puddle up towards you, you can actually see the external leading edge of the puddle and the internal leading edge of the puddle. And while you turn the external leading edge of the puddle to a liquid, the internal leading edge a split second later will turn into a liquid. It'll go from a solid to a liquid, and then that's when you can take the tip of the filler metal and add it to that weld puddle. Usually when guys get the rod stubs, it's because the internal leading edge of the weld puddle has still remain solid and not yet a liquid, but when you add into it, it will immediately turn into a liquid, and that's when you melt off from the side of the metal. Yeah, so usually like if a guy, like a 36-inch and even a 24-inch would be a little bit very difficult backfeeding looking through the gap technique. You could do it on an 18-inch, but it's more helpful with the 532 because it slows down all your travel, how the puddle flows, so it actually slows everything down, so you actually have more control than you would over a 1/8 on this size of pipe. It's just easier just to control the flow, but when it gets to a point where something really large, it's easier to use this particular technique. But for aesthetics and more control and a higher quality root pass, you want to use this particular technique right here, because this makes the weld deposited weld just look like a robot welded it basically.
Now, I'm not quite as good as Travis, so mine might not look like a robot did it, but I'm pretty sure Travis's side will.
Well, actually, I was telling Dakota here, you see, many years ago, I used to be the youngest B-pressure welder in Alberta, and then I used to be the youngest rig welder in Alberta, and now I'm older than everybody, and even there's younger, more talented, and even the younger talented welders are even better looking than me. So, a little sad. Dakota's here is only 24, and he's actually, he's actually very highly talented. I was telling them he's actually more talented at his age than I was when I was his age. So when he gets my age, then he's going to be even better than me,
It's because I got to learn off you. You get trained by Travis.
I can't let that happen.
Yeah. You don't get much better than that.
The root's going in nice though. A really nice root.
Awesome.
Yeah, really nice.
So a lot of people not underestimate, but take for granted cup size, changing it, using a variety of cups.
Yeah, it works.
We've noticed over the last while using this technique and locking the cup in the fab shop too, that cup size and your bevel size plays a huge role in weldability. And adjusting, changing that cup according to bevel, changing that gap according to pipe size. It changes how it welds, it changes how you can walk, your technique for walking, whether it's rocking in the bevel or walking on top. It makes a big difference, and it's something that can be easily overlooked. So a filler angle like this would be a lot more common on bigger pipe, where you can't feed from the top. But it's that balance of trying to achieve as much angle, trying to get it as direct into the puddle to avoid those nubs, but still being able to feed, reach your filler wire, and have it long enough to reach your puddle and get the most out of it. And the same as back feeding, looking through the gap, you try and keep that filler wire in the puddle consistently, quench that puddle, add that support, and keep control over your weld. Now with carbon steel and 70S6, we use a constant feed technique. When me and Travis were tag teaming 304H, so 36 inch, 24, and 46, some weird sizes on that job actually. That filler wire was a custom wire for 304H, an ER 16-8-2. And with that stainless alloy, there was a little bit of sluggishness to it. So our technique, we adjusted to be a dip and keyhole. And back feeding like this, you washed it out, eat your bevels away, add a little bit of metal to the back of the puddle. Wash your bevels away, develop a tiny keyhole, add filler to the back. So depending upon your alloy you're welding, the filler wire you're using, purging, no purge, it really dictates your technique, and you would kind of have to adjust on the fly as you get used to the material. As well as the stainless 304H we did some 2.25% chrome. And with that material, you can purge it, but you don't have to. So we did our position welds without a purge, being the low percent chrome. But chrome being a little more sluggish, as well as having those oxides, the constant feed was a crucial technique with that material. Otherwise, we found without introducing the deoxidizers of the filler wire, the puddle became really dirty and sluggish and didn't want to fuse properly. So alright, so cut the tack out, feathered our stop start, made sure we had that nice consistent gap where your filler wire isn't going to catch anywhere. Let's close this side up.
Yeah, usually anytime you do backfeed the filler metal, whether it's this particular technique, walking the cup, or else like the looking through the gap technique, you always want to ensure that the gap is always uniform, always. Quite often it will, with heat, it will close and pull and shrink on you, especially stainless and especially nickel alloys. And you do want to always maintain a uniform gap, because you can always see that weld puddle. And actually what happens is that when it starts closing up on you, a lot of inexperienced welders will still try and weld with it, and they figure they can just see a keyhole and kind of keep going, but they actually see like a false bevel, like a false bevel tip is what they see. So they see the bevel tip, and then the filler metal, because it can't go onto the leading edge or even outside of the weld puddle because the gap is closing up so much. It actually ends up a very ununiform root, very heavy root pass, loss of control. So always being able to have right now we can actually use a current that's very controllable. It's lesser current, So you can actually slow down your movement. You can actually watch it move from bevel tip to bevel tip. You know, the left side will solidify when you move to the right side, and vice versa. It's a very easy control. It just kind of comes off the weld filament metal like a funnel, you know. So, but you know, basically when the camera's off here, we'll just knife through the gap, make sure it's all uniform, make sure we can brace it against attack. Also, the other thing too here is you see quite often out in the field there, like what we're doing here. You know, say if there's like a wall here or something, or quite often in very difficult times, a welder wants to be able to weld with both the left hand and the right hand. It's very essential when you're a TIG welder. It's very essential to be able to weld with both hands. Dakota has the right hand side. I took the left hand side, and that way, you know, you can see our faces from where we're standing, rather than you know, having our back turned and seeing our back here. How's the current, Dakota?
Current's good. Pretty much carbon steel being how it flows. Very similar technique. Instead of freehanding it and going bevel tip to bevel tip, I'm just rocking the cup in. You know, we're using a number 8 cup with a gas lens. That way you got good gas coverage, no worries about porosity. And that number 8 cup fits right in the bevel. I'm just rocking it back and forth.
And essentially, like what Dakota's doing here is, you see, we're welding at a little bit lesser current. You know, a lesser current could mean anything really. It could be, for us, it's a little bit colder than what we're welding at the bottom here. But we're welding at a little bit colder current, and we have the filament metal. It fits very nicely. It moves very freely in the gap here, and so we're actually able to just have it flow off very, very nicely. We're just moving from bevel tip to bevel tip, not up the bevels or nothing like that, but it's only from bevel tip to bevel tip. And then we can actually, when we move to the left bevel tip, we'll see the bevel tip on the right solidify. When you move to the right bevel tip, left hand bevel tip solidifies. So we actually have enormous amounts of control, and just walking the cup allows you for very, very consistent. So essentially we're going for a very consistent root pass. The looking through the gap technique and freehanding does offer, you know, you have a little bit of freedom of range and motion, but
Bigger bore, trying to reach under a 36 or a 48 or a 52, you're reaching all the way under like that, and locking the cup gives you that. You can rest your cup on there. A little bit more steady, a little bit easier, a little more comfortable. You're doing a weld that size, you're on it for a long time, so being comfortable is a key part. All right.
okay. And basically what I'll be doing here is I'll be able to visually see my, I'll be pulling the weld pull up towards me, so I can actually see the external leading edge on the outside of the pipe, which is being melted by this heat source here. That's basically all it is just a heat gun. And I'll be able to see the internal leading edge melt. So the external leading edge will turn to a liquid first, and then a split second later the internal leading edge will turn to a liquid. So say, for example, if I'm kind of feeding at this angle, if I'm not too careful, the internal leading edge might still be a solid before it turns to a liquid, and I might kind of slide down a little bit past it and actually melt off prematurely off the side of the filament metal, and that's when you get like the rod stubs. So one way around that is actually just kind of watch the internal leading edge. You can also change the angle so it's more direct on, melt off the tip of the filament metal, or else you can watch your external leading edge and then the split second later the internal leading edge. So it's just basically you're lining up your line of sight. How many amps does it say on the remote there, Dakota?
You are at
So might get you just to turn me down a little bit just to have a little bit more control.
99 amps will go, there's 97,
Maybe a little bit colder.
96, 95.
Thank you. Yeah, because essentially what I'm watching here is I had Dakota turn me down just a little bit because I can see how the puddle is solidifying from when I move from bevel tip to bevel tip. And I just kind of wanted it a little bit colder so it would solidify that puddle a little bit when I move away from one of the bevel tips. And that way I don't get a heavy root pass or nothing.
Yeah, and having that large molten puddle, gravity will affect you more so, whereas having that smaller puddle where it freezes by the time you travel to the other side, gravity has less time and less of a chance of giving you that suck back or undercut. And that's something to really keep an eye on the bottom. You know, bottom you're worried about suck back and underfill concavity. The top you have gravity fighting the opposite way. That wants to suck your puddle down and give you excessive penetration. So keeping gravity in mind, using your heat to your advantage, adjusting accordingly is something you have to pay attention to.
So you can use the bevels themselves as a heat source, or sorry, as a heat sink. I can kind of wash up to it, watch the puddle pull over and solidify on the opposing side, and I can move over. Sometimes I'm just using continuous view technique, and I'm coming up to the tack here. There we go.
Another thing to keep in mind with running a grinder through that gap is the potential for putting a burr, leaving an edge in there, and that's something might not always cause issues, but it has the potential. So using either a hacksaw blade or a banana knife or something along those lines, depending what your site allows, pulling those burrs out so they don't fuse to the edge of the puddle and leave essentially a nub sticking out, and then X-ray picks up or visual. So it's just one other thing to keep in mind to ensure that perfection of a finished product.
Now right now we have a welding current that is very, very controllable, especially the machine. Like this machine is sweet, you know, it's awesome. And it's just like, we have so much control, and like Dakota he's just like taking his time right now. It's just insane.
Yeah, I'm coming off that tie-in, so I want to make sure I'm nice and molten before I start going.
So like literally all we're doing is just kind of moving from bevel tip to bevel tip. Like we have a nice current, it's so controllable that all we literally have to do is just kind of move from bevel tip to bevel tip and just kind of watch the puddle just fall into that weld puddle. It's just insane. And then usually as we change out the pipe, so right now we're actually using a size 8 cup, and you know what, we can do the root pass, we can do the hot pass for that as well. And then usually as we get you know, further and further out from the root pass, then we'll start switching up to maybe a size 10, size 12 cup. You know, and that way, it's actually like a wheel. Think of it as like kind of a wheel. Like right now, the smaller diameter will actually fit nicely. We can actually walk the cup. But as you start feeding more and more outside of the bevel, you start walking on deposited metal, and also you start walking on a very wide area. And your small ceramic cup is now kind of too much movement, way too much movement. So if you jump up to say, you know, size 10, size 12 ceramic cup, you can still walk the cup identical to what we're doing with the size 8 cup here. And because it's like a very small diameter, when you increase the size of the electrode, or sorry, the size of the ceramic cup, you know, so like a size 12, you actually don't have to, you can actually get a lot of travel distance left to right with just very minimal movements. This is more a surface area, surface diameter.
So the best thing, this did tighten up a little bit. All that heat, of course, travels to the top, so generally your pipe is going to pull and shrink at the top the most. And every once in a while you can feel it tighten up. You know, you can't quite feed the filler wire. On something crucial, or an X-rayed weld, or practice, or a test, or whatever, the best thing to do is just stop, take that grinder, run it through quick. Instead of trying to fight it, you know, you're more prone to issues. The potential is there. You stop, you take that 2 minutes, you run it through, you clean it up, and you're good to go. You're not getting called back with a red ribbon or a blue ribbon saying there's repairs on it and getting ran off a job.
Now usually when we get to the top of the pipe there, quite often it's say if it's just one person doing this, you're doing the tie-in, it's easier if you go onto the other side of the pipe and then just kind of pull the tie-in up towards you. It's also kind of easy to weld downhill, but that's not really in the weld procedure unless it is allowable in the weld procedure. Then if you have a weld procedure, say, that offers uphill or downhill weld progression, then you know. But right now I could say, hey Dakota, I'm up certain amount here. Can you pull my side up? And you know, Dakota will. So
exactly how we closed up the stainless tie-ins. When you're on one side and I'm on the other, it just makes it easier. I'll close up your top, you close up my top. Let's get hot passing, right?
Yeah, and then usually what we'll do is we'll leave an area so we can kind of look through, make sure one side's good, make sure the other side's good. We'll nicely bevel, nicely clean, prep, nice high-end prep. And then, you know, when one of the welders is closed and the other welder, they'll be watching that tie-in, ensure it's a really high quality tie-in as well. So it's nice to have extra set of eyes on there while you're doing the welding.
All right. And as well, sometimes I like to, on final tie-ins, I leave a slight window at the top. I'll finish the root 85, 90% of the root. I'll leave a slight window at the top here, and I'll hot pass the bottom up, just in case there's a chance of suck back. You know, you leave that window, you hot pass the bottom, you know you're good, you close that up, hot pass, and you're good to go. So, get far enough for you?
Oh yes. So we have a tack at the top here, and what I'll be doing is I'll just kind of just knife it. I'll make sure the grinding disc goes in here really nicely, and my filament will be able to fit very, very nicely, so I'll have a lot of control. And while I'm welding, it's not going to close up on me, which is very, very critical. And then so I'll weld up maybe up to about here, and then we'll remove that tack there, feather, and then, you know, maybe myself or Dakota will here take it, do the tie-in.
So right now for this video, we're using a 200 amp air-cooled torch. And this is something very similar to what we'd be using in the field. But the nice thing is with Miller is this machine actually has a water cooler built underneath of it. So if you're in a shop setting, say, you know, at a wheel rolling out pipe, you'd run off a water cooled setup, and you could run much higher amperage for a much smaller torch. But in the field setting, it's not quite practical to be carrying a water cooler with you, or trying to have cables stretch across grading and gravel and mud. But a 200 amp torch like this, it can still handle the heat. Throw your hot pass, your fill, and you're capping with TIG, and it's all no issue. You just hook up your negative lead to your TIG torch and a gas hose, and it's just simple, easy, and no hassles in the field situation. But the nice thing is there's many options for torches, whether it be water cooled, air cooled, flex head, rigid head. Your options are almost endless. You can choose based on what you're doing to suit your situation the best and benefit your job and productivity as well as quality.
So usually on here, the last 1 inch is usually the most critical. That's where a lot of weld defects end up happening, is because a welder will just try and close right in, but you could have a little bit of land, or it could close up on you. You could actually end up with a little bit of suck back, or you know, missed an edge, or you could have messed an edge or something. So leave the last 1 inch. You just kind of feather it, make sure it's all good. Open the gap, make it uniform, perfect, and then close it. And now, because the tie-in is actually at 12 o'clock, I can actually just go like this, walk it towards myself, because I'm not welding downhill. I'm actually welding, in a flat position.
This is something that comes very handy on big bore, where to reach over top forward is very, you're going to be on top of the pipe. It's an awkward position, whereas you can reach that last 6 inches, reach over with your dominant arm, close right up, and you're good to go. Another real handy thing to have when closing up is the remote, and have your tag team partner, your helper, adjusting as you go. So how's your heat there, Travis?
Pretty good. It may get you go up just a little bit pretty soon.
There's 95.
And maybe go up 5.
There's 100.
Yeah, maybe another 5, up to 105.
105, and just using that additional heat to fuse into the other side of the weld. You feather it out, you make that nice ramp, and then that little bit of additional heat just ensures you are 100% penetrated, 100% fused, and ready to taper out and shut off.
I thought that was fantastic. This welding technique, looking through the gap technique and the walk in the cup technique on the Miller Dynasty 400. Dakota, what are your thoughts?
Just a couple different techniques, depending on your situation, your material, your setup, room. It's just one of those the multiple tools you have in your toolbox that you can grab, and we're finished up. We got to get going on to the next thing, so we're closed up, we're rooted. Time for the other guys to fill it.
Oh, it's nice. And this Dynasty 400, I own these things. I have so much control. It is just incredible. Like, there's no stress, no anxiety here. It's just like, this is so effortless. Thank you very much for watching, and you'll see more on the WeldTube YouTube channel and also the WeldTube Instagram for further videos with the WeldTube squad here. Thanks for watching.